Good morning, students. We are discussing on railway and airport engineering. Well, in this lecture, we will discuss about one of the railway engineering part, and that is the track junction. Well, what is the track junction and why we need to provide? What is the objective of track junction? So the answer is the track junctions are formed by the combination of points and crossings. The main objective of track junction is to transfer rail vehicles from one track to the another one, or we can say to enable the train vehicles to cross from one track to the another one. While depending upon the requirements of traffic, there can be several types of track junction with a simple track layouts. Let's see what are the most commonly used track junctions in the Indian railways. So those are the turnout of similar flexure, turnout of contrary flexure, symmetrical split, three-throw switch, double turnouts, crossover or scissor crossings, diamond crossings, then gathering lines, gauntleted track, then triangle, double junctions, and single slip and double slip. So these are some of the most commonly used junctions in the railways. So let's discuss about those. The first one, that is the turnout of similar flexure. Well, turnout of similar flexure is one of that continues turnout to run in the same direction as the main line, even after branching from the different one. Here you can see in this figure the second turnout, or we can say the second branch line is also in the same direction of the main line. Okay, just at another degree. So the degree of this turnout curve is higher than that of the main curve. So at such type of location, this kind of turnouts or the track junctions should be provided. Well, for that, degree and radius of this turnout curve can be found out by dt is equals to ds plus dm, and rt is equals to rm rs upon rm plus rs. Well, this r is the radius and d is the degree of that particular curve. Okay, so ds is equals to degree of the outer rail of the turnout curve from the straight track. Okay, dm is the degree of the rail of main track on which the crossing lies. That is the kind of the inner rails. Then dt, that is the degree of the rail of turnout curve on which the crossing lies, which is the outer rails. Okay, here you can see this is the outer rail of the turnout and this is the inner rail of the turnout where these crossings meet. Okay, so that degree and same the radius is being covered. Okay, the next, that is the turnout of contrary flexure. Well, a turnout of contrary flexure is one of that takes off towards the direction opposite to the main line curve. Here you can see the main line is going in this direction, where the turnout is completely going to the opposite direction of this main line. So this type of track junctions, this is the track junctions. Okay, so this type of track junctions is being called as the turnout of contrary flexure. Well, again here the degree and the radius of that curve is matters, and that can be found out by these two formulas. Okay, and this is the notation of this formulas. Well, the another one, that is the symmetrical split, the third type of track junction which can be used. Well, when a straight track splits up into two different directions with the equal radius. Okay, the layout that is known as the symmetrical split. As we can say, the symmetrical, that means there are two different equal part. So same way, the two lines, we can consider any one of them as a main line and another one that is as the branch line. Okay, so if these two lines are being divided, or we can say are being diverted with the equal radius. Okay, so that type of track junction is being called as the symmetrical split. Well, in other word, we can say this kind of symmetrical split is a contrary flexure because they are also going in the opposite direction. Okay, in which the radius of two curves are the same. Well, there are some of salient features of this symmetrical split. That is, like, the layout consists of a pair of points, four curved lead lines, then two check rails. Also, the layout is symmetrical about the center line. The layout provides the facilities for diverting the vehicles both towards the left and the right one. It is suitable for locations with the space constraints. Okay. Another track junction, that is the 3-through switch. Well, in the 3-through switch, or in this type of arrangement, two turnouts takes off from the same point of the main line. Okay, and this 3-through switch can have contrary flexure or the similar flexure. Okay, because these two lines we can consider is in the opposite direction. Yes, okay, or this can have the same similar flexure, such as we can say the main line. Okay, this is going in this straight track, the another one may be going with the this straight track, and the third one that might be parallel to this track. Okay, so that can also be considered as the similar flexure. So 3-throw switches are used in congested goods yard, okay, where we cannot provide larger area, or we cannot provide the larger radius to that curve. So at such type of locations, we can use this type of 3-throw switch. Okay. So these are absolute now, as they may prove to be hazardous, particularly at the higher speeds, because the use of double switch may lead to derailments. Okay, so when you provide such kind of 3-throw switch, there is a restriction towards the speed of the train. Well, the next one, that is the double turnout. Okay, this double turnout, or we can say a tandem turnout, is an improvement over the 3-throw switch. Okay, in a double turnout, turnouts are staggered and take off from the main line at two different places as shown in this figure. Okay, so the main line is going in the straight direction, while these branch lines are being at the curved place. Okay, where you can see those two lines are being started with these different locations. The another ones, those are started at the same point. It might be the first branch line would be moved from the A and the second one will be started from the B, but here you can see these two different branch lines are being started with the different locations. Okay, this eliminates the defect of 3-throw switch, as the heel of the two switch are kept at certain distance from each other. The distance between the two sets of switches should be adequate to allow the room for the usual throw of the point. The double turnout can be similar flexure when the two turnouts takes off on the same side of the track. Okay, so this is the double turnout with the similar flexure. Okay, because it is going in the similar direction, while this is the double turnout with the contrary flexures. Those are being diverted in the different or the opposite direction. Clear? The next, that is the crossover. Well, when two adjacent parallel, or we can say the diverging tracks, are connected by two sets of turnouts with or without the straight length between them, the connecting line, which is known as the crossover. So it is simply like when two lines are moving parallel, two tracks are moving parallel, and if the train has to change the track from the first line to the second line, and a kind of a crossover, or we can say the connecting line, if we provide, so that is known as the crossover. Okay, the second, that is the scissor crossings. Well, a scissor crossover is meant for transferring a vehicle from one track to another track, or we can say the vice versa. It provided where the lack of space does not permit the provision of two separate crossovers. Okay, so the scissor crossings can be used where the separate two crossovers cannot be provided. Okay, it consists of 4 pair of switches, 6 acutes, then 6 acute crossings, then 2 obtuse crossing, check rails, etc. And this type of crossings are used in goods yard, and also for some of the shunting operations. Okay, so this is the kind of use, or we can say this is about the scissor crossing. Okay, that only and only provided when the crossover cannot be provided, not only single crossover. For two separate crossover is not possible to provide, at such place we can use this scissor crossing. The next track junction, which is the diamond crossing. Well, this figure shows a diamond crossing, which is provided when two tracks of either the same gauge or of the different gauge cross each other. Okay, it consists of two acute crossings A and C, as shown in this figure. These are the acute crossings, and two obtuse crossings, that is B and D point. Okay, a typical diamond crossing consists of two tracks of the same gauge crossing each other, but the trains from either track cannot change the track. Okay, the diamond crossing should be avoided on the curves as far as possible, otherwise the speed restriction will have to be imposed on such crossings. While talking about the gauntleted track, well, this arrangement is adopted when a double track is to be narrowed over a short distance of the track. Well, here you can see in this figure, when there is kind of a repair work is being taken place in the straight railway track. Okay, and for that reason, if this particular train which is moving in the first track has to change its way from the to the second track, and after some distance it has to again take place the first track. Okay, so it such type of locations we can, or we have to provide such type of gauntleted track. Okay, this arrangement is necessary when one of the double track is under the repair, or the any kind of bridge is being under construction. Okay, well, this type of tracks are also used on the sections where the trains have to operate on mixed gauges, say the broad gauge and the middle gauge. Okay, for a very short stretch. In such cases, both the tracks are laid on the same set of sleeper. Okay, clear? Well, the next track junction, which is the triangle. Well, a triangle is generally provided in terminal yards for changing the direction of an engine. The turntable are also used to change the direction of engines, but they are very costly. So if enough land is available, then we can provide such type of triangle track junctions. The next one, that is the double junction. Well, the important feature of such type of double junction is that the layout of this double junction consists of number of turnouts with one or more diamond crossings, this depending upon the number of parallel tracks which is being available. Okay, these double junctions may occur either on the straight track, or it can be also provided at the curved main lines or the branch lines. Okay, Well, this can be the single lines or this can be the double lines also. Okay, so this type of double junctions is being used uh, where from the main lines to different branch lines has to be moved in the parallel direction, such as you can see in this figure, the main line 1 and main line 2, but from both of them a line has to be taken from the another direction. While the next one, that is the single slip and the double slip track junction. Well, for the single slip, this is one in which the track can be changed from one direction only. Means we can only change that direction, or we can only change the track from A to D or D to A as shown here. Okay, so this is called as the single slip, where the train coming from this direction can move from this direction only, or from coming from this direction and moving can move from the direction D. But in the double slip, it can be moved in the both the ways, A to D, okay, or D to A, or C to B, or B to C. Okay, clear? So these are all about the track junctions that we can provide on the railway tracks. Okay, I hope students you all understand this topic properly. Thank you so much for your kind attention. I will see you in the next lecture with one of the new topic. It is regarding on the railway engineering. Thank you.